Here is a fun reteaching video on how to solve two-step equations. And we might even get into some where we have to do some combining like terms on one side of the equation in one of the expressions in order to solve for that missing variable. So let's get started. You'll be able to look here and see they have some great examples on how we are going through, and look at that. They begin with moving the constant away from the expression that has the variable. And then they are going ahead and with that multiplication of the variable, they are dividing. Oh, look, there's a typo. They're dividing both sides by 15 to get the answer of 3. Now, you can go ahead and you can see there's another example. This one's a little more involved. As you can see, there are how many terms in this equation? So in this equation, we can see that we have the term a, 2a, -4, and 14. So we actually have 4 terms that create the equation. Now, of these 4 terms, some of them are like terms. So looking here, what are those like terms, right? So if we look at this, we can see that our like terms would be the a and the 2a. And so we have to combine those like terms in order to find ourselves back at a two-step equation. Once we're there at that point, again, we're going to identify the constant. That constant is -4. So I'm going to add 4 to create that 0 pair. I'm going to add 4 to both sides of my equation to get me down to that one-step equation. Now I see that multiplication is happening with that variable. So you see that there is division of 3 on both sides to simplify. So let's go ahead and see, what do we have here? Oh, another example. Probably one of the examples that you've been waiting for. That whole distributive property, I know at times can be confusing, or we might forget to distribute to all of the terms inside of the parentheses. So here we see that we've got this problem, 2 times the difference of 5x and 3. Now, first, of course, you're doing that distributive property, so they're showing you that the 2 times 5x, 2 times 5x is 10x, and then we see another distribution of 2 times, that's a -3, remember, so 2 times -3 is going to be our -6, and now we're back to a two-step equation. Identify the constant. The constant is -6, so we're going to create that 0 pair, and -6 plus 6 leaves you with the 10x, and then we have our 4 plus 6, which is our 10. And then we go ahead and we divide on both sides for that solution of 1. Now, you are going to be responsible for doing all of these awesome problems on this side. And I'm going to just go through and probably choose 2 of the hardest problems from the odd side. So let's see. In my head, I am guessing that maybe you're going, okay, Mrs. Courtney, number 3 is really hard. So let's look at that one first. Because we've got that fraction, and while we may not enjoy fractions, we should always know how to work with them. So let's just do some practice. Now here we see that we have 2/3 y plus y. We know that that y has the known coefficient of 1, so it is 1y. My like terms that I can combine together are going to be right here. My 2/3 y plus y. So before I can get into moving that constant to the opposite side of the equation, I'm going to go ahead and combine these like terms. Now, I can think about 2/3 y plus 1y. I may also want to take that 1 because I have a fraction I'm combining, and I might make it 3/3, right? We know that 3/3 is the same as 1, and since I'm working with thirds, I'm going to use that knowledge to make it 3/3. 2/3 plus 3/3, I'm going to get 5/3 y, and then I'm minus 4 equals 31. Okay, now it's looking a lot more like a problem we've seen before. Identify your constant. So there's my constant. I'm going to add 4, enabling me to get the constant away from that expression with the variable. I now have 5/3 y is equal to 35. I've been doing this in class a lot sometimes so that you're beginning to see the progression of how those smaller problems within the equation are working. Now I have my one-step equation. 5/3 y is equal to 35. Why is my color not changing? There we go. 5/3 y, remember, a fraction times its reciprocal changes the coefficient to 1. A whole number then. I'm going to do times that same reciprocal of 3/5. 35 is a fraction. It's 35 over 1. I now can look at how will I be able to cross reduce. So 35 and 5 can both be divided by 5. There's 1 5 and 5. There are 7 5s in 35. 7 times 3 is 21. 1 times 1 is 1. So I can leave 21 as that whole number. These two give me a coefficient of 1. So I can say y is equal to 21. Let's see. What would be another one? I'm thinking one with distribution and one that looks a little different to start with. So we're going to look at number 9. In number 9, we have 16 is equal to 2 times t minus 1 minus t. Okay, now we do have two variables. Let's just take our time though and work through this. And we're going to do that by identifying where to start. Because there are parentheses and I can simplify when I see parentheses and I see more than one term inside the parentheses. I mean, you guys, the amount of math language that we're using here, I'm so happy we reviewed all of that. So we got 16 equals 2 times t, 2t. Now remember, this term is -1. 2 times -1, -2 minus t. Okay, so we have dealt with the parentheses. They're no longer here, but we see 2t, and that's a minus t because it's 1t. 2t minus t leaves me with t. Minus 2 is the same as 16. Now, you might also write this. I see 2t minus t. That's t. And then there's this -2 here, right? You can do that. Remember, that t is positive. So you can actually write the expression either way. Either way works. In both cases, the 2 is negative. So I'm going to move -2 to +2. Because remember, we are working with always looking for that constant first. -2 plus 2 is 0, leaving me with t is equal to 18. Because I added 2 to this side, I've got to add 2 to that side. Now I can also come over here and I can add 2 just as well. It just looks a little different. And I still get my t is equal to 18. Okay, so again, this is a nice review on multi-step equations where we did that two-step process. The only additional piece was that we saw situations where we had 3 terms, right? We had 3 terms on one side of the expression. And so what we were looking for is that idea that if I have 3 terms on one side, can I combine like terms? That takes us back to the beginning of the school year. So remember, you can always go back and re-watch this video if needed and have